Welcome to the Case for Conservation podcast, where we question some of the less convincing conventional wisdom in the field of biodiversity conservation. In this month's episode, I'm revisiting a previous topic from a slightly different angle. In September 2020, I spoke with David Duthie about the links between nature and COVID-19. This time, it's the links between biodiversity in particular and zoonotic disease more generally. There's a lot in the media these days about how protecting biodiversity reduces the risk of zoonotic disease spillover, and hence the risk of epidemics and pandemics. I asked Dan Salkeld about this. He's a disease ecologist at Colorado State University. In particular, we discussed whether it's reasonable to generalize about such a claim. There seems to be good evidence that biodiversity does reduce spillover in many cases, but how universal is such a claim? What is the science behind it? Are there exceptions to the rule, and what are the risks of implying consensus and causation if we're not completely sure about all of this? In the podcast notes, there is again a list of timestamps in case you'd like to skip to any particular part of the discussion. And on the episode webpage at www.caseforconservation.com, you'll find a list of resources, including a few of Dan's papers on this topic, and a couple of papers by those who agree and disagree with him. Please feel free also to contact me through the website if you'd like to ask or suggest anything. It's always really nice to get to know listeners. Could you perhaps just start by telling everyone how you got into conservation and how you got into this particular role that you're playing in disease ecology?
Yeah, I always wanted to be a conservationist from a young age. And then I did a conservation fellowship at the University of Oxford with Wildlife Conservation Research Unit. And so they had people just who were admittedly stalled in their careers, and they paired us with PhDs and postdocs to get a feel. And the advice at that point for me was to do a PhD in something different from conservation so that I would come up with different perspectives. And I think I lost my way, and I got into disease ecology and how parasites and pathogens work in wildlife communities. And I think I'm slowly trying to claw myself back into trying to understand what are the larger implications of looking at disease ecology, which is great in itself, but I like there to be an application, whether it's conservation or whether it's public health, that it is beyond just the ecological descriptions.
Just to jump into the topic, there is some speculation about whether COVID-19 came directly from nature. But what's important for our discussion is, I think, that most infectious diseases do have their origin in wild species. And that means that the next pandemic is probably likely to be zoonotic in origin. So broadly speaking, what are the factors that could cause zoonotic disease to spill over into human populations?
Yeah, really generally, I think it boils down to contact. So what we are looking at in this era is a change in contact with hugely growing human populations and more fragmented wildlife populations. And so we're changing balances and interactions between wildlife and humans. And while spillovers may have occurred repeatedly throughout human history, what's happening now is that if they do occur, there's that chance for it to suddenly take off and start spreading in the human population. And really now we're all connected, and we have huge numbers. So the number of susceptible people and the variation in likelihood of whether an infection can take off in that human and then adapt so that it can spread to new people is kind of an unparalleled rate that we haven't seen. Really now we're super focused on these outbreaks that have happened in the last 10, 15 years, and they all seem odd and idiosyncratic in their own ways. But it's not. I mean, these things have happened. We have had plague epidemics, and we've had smallpox, and we've had flus that come from animal sources. But I think in part it's the speed at which this travels now. And I think there is an increased likelihood that when something does jump, it can take off. That might have been the difference when we had small fragmented populations that it just didn't have fertile ground to spread, or if it did, it burned out pretty quickly.
So there's been an ongoing debate in the literature. I don't know how far back it goes. Maybe you can mention that as well. But about the relationship between biodiversity loss and the risk of or spillover of zoonotic disease. And one particular kind of aspect of this that comes up quite a lot is something called the dilution effect, by which biodiversity is said to reduce pathogen prevalence. First of all, could you just explain what's meant by the dilution effect? And is it the only reason for the argument that biodiversity reduces spillover risk, or are there others?
Yeah, I'm going to go back a little and make this slightly anecdotal. So I was doing a PhD in Australia and wandering these tropical rainforests, trying to look at parasites in lizards. And I came across this American abroad student, and he asked me what I was doing, and he knew the Latin names for the lizards. And I was totally taken aback and asked him how he would know this kind of thing. He told me he was working in a lab in the States where they were looking at this relationship between biodiversity and disease prevalence, and in this case it was Lyme disease in northeast United States, and how as you have increased biodiversity, the prevalence of Lyme disease tends to decline. And so was this a way of being able to combine conservation and public health and ecology by interventions that keep or maintain high biodiversity, and in which case you could reduce the probability of spillover? And I think, like many ecologists, I was totally astounded by this as an idea. Like, it was perfect. And in a nutshell, just like this wonderful kind of coming together of different disciplines, and everything is a win-win. We have conserved nature, we have reduced public health, we have healthy ecologies, and what a wonderful thing. And so it has taken off, and I think lots of ecologists have found it really exciting. And the original description is very careful, and they describe the Lyme disease system in the Northeast. Brilliant. It's one of my favorite papers of how the amount of work they did to try to describe the system, and then how they went and looked at that as at a next level, and like what were the implications of doing transmission studies on wildlife. But I think what has happened is that it's become such a popular idea that people have kind of, this sounds really rude, but they've perhaps lost a little rigor in the excitement to then go onwards and find out, oh, and now we can show this in another system and another system. And it's become boiled down to what is species richness and what is the abundance of whatever pathogen you're looking at. And I don't think that that's a tremendously useful relationship to describe, because you're missing a lot of the interactions and mechanisms. And essentially you're looking for a correlation between two parameters, and they may not actually really be linked.
How far back does this go? I mean, when was this idea first presented?
I think it goes back a while back amongst malaria biologists. I think they originally kind of coined the idea, but and their framing of it was that if you have, you could use cattle as a way of attracting mosquitoes, so they would bite the cows instead of the humans, and so you could, increase biodiversity in a very crude way to reduce disease. And I think that's the background. What took off for me was this work by Kathleen Nogiadis and Rick Osfeld and Lisa Keesing in the Northeast. And that was in the early 2000s. So that first paper is 2003. And at that time, there was this kind of general excitement about looking at communities and ecology of those communities and the impacts on disease. And maybe it's not fair. Maybe it was done by other groups. But to me, as a disease ecologist, it was suddenly gaining this burgeoning excitement and importance.
Mm-hmm. And just back to the dilution effect, could you just kind of define what that is, especially for a non-ecologist?
Yeah, so in a nutshell, it's arguing that as biodiversity declines, so it's becoming less intact, or you're having impacts and you're removing species, or you're changing the abundance of certain species within an ecosystem, then diseases will become more prevalent or more common, and increase the likelihood of spillover or infection in humans.
Right. And then as far as I understand, biodiversity is what dilutes, right? So if you have a larger variety of species, then the number of species that can be hosts to a particular pathogen is reduced as a total number of the organisms in the system, right?
Yeah. So what you're doing is, so for example, and this is where the beauty of it originally was from is that if you have a certain finite number of ticks in a woodland plot and you start adding animals, or you have inherently the animals that were there, then ticks are biting all these different species of animals. So whether they're opossums or squirrels or mice. And mice are really good at infecting ticks with Lyme disease. They're really talented at it. And squirrels are less so, and opossums are less so. So if you have all those animals, the theory is that ticks are biting possums or squirrels, and therefore they're not getting infected with Lyme disease at the same rate as they would be by mice. And those ticks at the same time can't bite the mice because they only take 2 meals on small mammals. So what you're having is less likelihood that a tick will find a host that can infect it with a disease. And subsequently, those ticks that are then looking for a human or whatever in the next meal are less likely to have the infection.
Okay, I see. So, and then there's something which I guess could be considered the corollary of the dilution effect, which is the amplification effect. Could you explain what that is and how it relates to the dilution effect and how it works kind of in the opposite direction?
Yeah, I think what the current interpretation of the amplification effect is that, like you said, is the reverse. So if you are changing the host communities in a certain way, do you get this increase in disease as opposed to the decline? So you would get a negative relationship between biodiversity and disease based on the dilution effect. And then there's this opposite would be that if you have an increase in disease as a result of a particular community ecology. And I think curmudgeonly, amplification to me was more that you exacerbated disease in certain situations or certain timings, and it's less this kind of function of the community. And I also have a little kind of stick with it in that it breaks everything down to simply either disease gets reduced or disease goes up, and it starts to lose those kind of idiosyncrasies of what about fluctuating disease? Is the biodiversity at a certain time of the year more important for disease dynamics throughout that year? I feel there's more likely to be fluctuations that exhibit behaviors between dilution and amplification than just sitting there and saying it's either A or B, and that's going to be the answer.
I think I've also read somewhere that the spatial scale can also have an effect, right, on whether one or the other is happening.
Yeah, and I'm still having difficulties really understanding that. And I think there are 2 really important scales for this. And one is the transmission of the pathogen and its hosts. So if you're looking at a tick-borne disease, you want to understand how the tick moves and how those hosts are moving. That's a pretty small scale. And then you also have to be thinking about the scale of spillover for human populations, because that's what we're normally concerned about. But it could be a target species that's of conservation interest too. And how do they interact with the ecosystem that you're looking at in terms of disease transmission? And then you have to take on top of that, what is your impact upon the ecosystem? What is going on to biodiversity at whichever scale too? And so it's difficult to determine which is the best one to measure, and not just either use GIS and Landsat imagery because that's the scale that is available to you, or go out and collect a hectare grid of 100 small mammal traps because that's the scale that you're used to working at. And so there's definitely some more thought that needs to be put into how do these all intertwine, and should we be changing the investigations scale, and both across space and time.
So based on all that, you would think that in the scientific literature, this is still very much a hot debate, but what is the sort of current state of things? My general impression is that many papers in the literature are making a fairly generic link between biodiversity and the risk of spillover of pathogens, saying that the biodiversity does reduce the risk. And quite often they're giving that message without really saying much about the mechanisms. So what is the sort of general state of that discussion?
I think this is the closest I'm coming to being a part of the climate debate, like people who, the 99% of people accept that climate change is happening, and the 1% are the crazy fringe who will never accept whatever data is thrown at them. And sometimes I get really alarmed that, am I doing that? Am I just sitting here going, I will not accept that the dilution effect can happen, because to me, it just doesn't work. And it depends. So an article will come out one Monday in PNAS saying, we've nailed it finally. Here's a great meta-analysis. We've looked at it all. in numerous systems, and we've come up with general trends to, yes, dilution effect works. The more intact the system, the lower the risk of disease. And 2 weeks later, someone will come out and say, I've just done a great study, which really shows in this case, the dilution effect does not work. And I think everyone sits there fuming in their offices about, well, the data are imperfect or their approach was imperfect. And so I guess, by that nature, I don't think the debate is done. I don't think that there is necessarily a neat answer. And I do find it somewhat amusing that we should be coming up with some consensus on what is obviously a massively complex question with multiple systems that are known for their complexity. And I can see the appeal of coming up with one nice general picture, but it's not something we can come up with anywhere else in ecology. So I don't think the answer is clear.
Mm-hmm.
I will pick and select my sources to back me up on that.
Something I find interesting, having trawled through the literature a bit myself, something that's interesting is that there are more people saying that there's a link between biodiversity and spillover risk than there are actual studies to base that claim on. And based on that, and also what you've said now, and also just the total number of empirical studies that exist, and considering how many could be done, among the pool of what could be done, it strikes me that there's a lot more empirical research to be done before we can really start drawing conclusions.
Yeah, I think there's a brilliant paper by Gottdenker et al., and I might be getting this wrong, but in it, they say really tongue-in-cheek, they notice that same trend, and they say, it seems that there are more reviews on this than like first-hand data, and then they acknowledge that they've just contributed to that because they've done another review. And I don't know whether that's just people trying to get really attracted by this, what seems like a wonderful win-win situation that it keeps getting addressed, and because these are major issues, I think. But I think, more empirical work needs to be done, and I would say it would need to include other aspects. So from what I remember, looking at the impact of spillover or human disease incidence for whatever pathogens, whether they're new or not, in a conservation context is really lacking. People tend to use this land use as a proxy for conservation, but I'm not sure how many studies look at, here's a conservation initiative and here's the conservation management, and this is the impact it's had upon disease, or we look at cases and controls of conserved land versus not conserved land, and how does that impact people. And I think that's still a major piece of evidence that's lacking. And I don't think that it would, like I said earlier, I don't think it's going to come up with a general answer, but it might start to let us understand, given a particular pathogen type, and given a particular mechanism of transmission, and given particular human demographics and behavior, what would we be expecting and what would we be able to do to get the best situation for conservation initiatives and public health.
All this said, I think the evidence does generally seem to point towards biodiversity decreasing the risk of zoonotic spillover, sort of generally, if you take the pool of empirical studies. But you have written about the perils of claiming that this is a causal link, when in fact all we have is a bunch of correlations which might be pointing more or less in one direction. Could you explain kind of the nuance there, why the difference between causation and correlation can be quite profound, or the implications of that can be quite profound?
Yeah, I think it exists in both disciplines of ecology and epidemiology, right? We have this thing called descriptive epidemiology, descriptive ecology, where we go out and we start to try and describe what's going on. So what are the numbers of human cases, and what are the other factors that we can look at? And that's great as a first step. And this, I think, is where epidemiology is a little bit better than ecology. They have a lot of well-established tools to then say, well, this looks interesting, but let's look at cohorts of people over time, or let's treat different peoples over time and compare the treated versus the reference populations. And that's where you start to understand, are the mechanisms that you think are occurring really occurring or not, because you control for them. And I think ecologically, the scale that we look at, it's very hard to do that. So we often are happy with a correlation between X and Y. What's worse, though, is you can start to look at the health data from a conservationist, and I've done this myself. I'm casting the first stone. That you can start, health data is often reported and publicly available. So you can start looking at the correlations between your ecological questions and then use health data as an outcome. And what happens is often that's not related at all because these are collected at different scales. They're portrayed at different scales. They're aggregated across counties or states. And you lose all the variation that you might be looking for. So one example of this that I got very excited with, so this is a friend and colleague of mine, Jean Tsao, who got frustrated at this kind of correlations that kept on coming up. And she just said, there's more Lyme disease in the Northeast, so you might as well correlate it with fried chicken because that is a southern thing and therefore we can correlate it. And she said it in a throwaway remark, and I thought this could be genius. And so literally it took me 4 minutes to download Lyme disease numbers per state, and it took me another 4 minutes to find fried chicken restaurant numbers per state. And then we started correlating it, and we found a correlation between mammal diversity was not statistically quite significant, but it was nearly there. But if you started to look at fried chicken restaurants, the correlation was statistically significant and stronger. And then we took it another step and we correlated it with obesity rates in these states, and it was even better and more explanatory. And we could come up even with nice explanations, right? So you could say, well, people with eating fried chicken restaurants become more obese and therefore are less likely to be out recreating in the woods, so they're not even exposed to ticks, and that could explain it. But it's all totally spurious. But it was really easily done. And much to my horror, once you realize how easily this is done, you can find examples in the literature, like in Science and Nature and PNAS and Ecology Letters, that do this for different spheres and different questions. And they're coming up with relationships that are statistically significant and look convincing. And if you're not sitting there with a skeptical eye, you can be convinced, but they're wrong. And they shouldn't be given any time unless you follow it up with a second study that says, I'm going to look at this and I'm going to work out people who eat in restaurants serving fried chicken, are they less likely to have Lyme disease over the next 5 years? And that's a lot harder to do and a lot more rigorous and a lot more logistically involved. And I think that's why we like to stop at what a great correlation. I'm going to run with this story.
Mm-hmm. I can imagine that effect being sort of amplified by the fact that negative results don't get published that easily. So, if a researcher, for example, in the case of biodiversity and spillover risk, they look at something and they find sort of a weak effect. Probably a weak effect is the one least likely to be published. A strong negative or a strong positive effect will probably get published, but a weak effect is the one that's least likely to make it into the literature. And we don't really know how many of those are out there, right? How many times it's been tested and failed to produce a really strong correlation.
Absolutely, and it's an issue for all of science. It's not just this dilution effect, and that was part of what kind of gave me some impetus to actually look at this more closely. Is talking to folks, often working in more of the human public health sides of things, and conversationally chatting about studies, for example, done in Mexico, where they just couldn't find this relationship and they were frustrated by it, but they decided to look at something else instead. And then say, well, did you publish those results within the other study? Are they part of like just descriptive results? And like, no, because they weren't significant. And we tried to address that in a study that you can look at this kind of publication bias and you can try and work out, are the more exciting studies the ones that get published? How do you quantify the number of studies that weren't there? You can use some statistical tricks to try and look at what you think might be missing and then work out how many studies seem to be missing. And we suggested that perhaps there was a publication bias, but others have come afterwards and they've done analyses and they've said no, they think there's no aspect of that. So it's a conundrum, but I think intuitively you're not going to publish the results that aren't exciting.
The last guest I interviewed, Randy Sheckman, we were talking about a similar kind of thing, and he said that there's now an online archive where non-published results can be stored, and he regarded that as a godsend, a really important thing, and I can see why he says so. But I didn't get the chance to ask him or to mention that a lot of people, myself included, didn't know that even existed, whereas the scientific literature is relatively easy to access. So I guess that those studies, those non-significant or not very interesting results studies might be gathering there, but are very seldom accessed unless someone really is setting out to look for them. Do you think that's the case, or are more researchers becoming aware of that information?
I think there's an analog here with randomized control trials for pharmaceutical treatments. I think there are procedures and programs where you have to log potential studies so that they can be found to say, well, why didn't this get published? And the answer would be in those logs of, well, because there was no significant effect. And I think it's, I guess there's potential to do it, but I think it's often, it falls by the wayside in a very human way of, well, how much time do you spend publishing results that weren't exciting, either statistically or to you at that stage, compared to publishing what you do think is really exciting.
Mm-hmm.
But there's definitely a bottleneck of relationships that aren't true, even after being tried and tested, that we are unaware of. So there's that natural bent towards sticking with the shiny, kind of exciting results.
So then kind of looking at specifically at the links between biodiversity and spillover risk, there is this kind of tricky balance to be struck between getting the nuance into the message, but also getting the general public to understand the summarized, the elevator pitch version of events. And the general tendency is to grab onto maybe one fact to the exclusion of the others. Do you have any thoughts on how to keep the public cautious while also being precise about the science? So I know this is not really your job as an ecologist. You're publishing in the scientific literature, but you are also talking to people on a lot of radio shows and that kind of thing. And I guess that you're talking about specific examples like ticks and Lyme disease. Maybe that makes it a little bit easier. But generally speaking, how do you kind of get that message across that on the one hand, we don't know that biodiversity is always going to reduce spillover risk in any particular circumstance. On the other hand, we also want to conserve biodiversity. We want people to consider biodiversity important, even if it doesn't help us to reduce spillover risk. So any thoughts on how we communicate those dual messages?
I guess transparency might help, and that there's an acknowledgement. I think I understand what you're trying to say is like, do things just they almost get given their own momentum, and it leaves your mouth, and then it's handled by press or media, or it's interpreted even wrongly. Someone hears the same thing, but it's interpreted and put in a different context.
Do you think it's the fault of the public, or do you think it's the fault of the messaging? Because I'll tell you that what I've seen, since COVID-19 hit the headlines, what I've seen in the mainstream media and even the messages from big organizations to which this is relevant, the message that they're putting across is a very generic one without much nuance. Conserve biodiversity and you'll be looking after your own health. And that may be true in the majority of cases, but there are cases undoubtedly where it's not true. I can give you actually one example. Is a paper, I forget who it was or when it was, but I'll put it in the reference list. But it was looking at the diversity and abundance of parasite organisms and how that would be affected by climate change. And the conclusion was that there would be a reasonably large impact on hosts. You'd lose a few species and a few populations, but the impact on the parasites would be far greater. You would lose more species of parasites, et cetera, et cetera. And that was the effect of climate change on habitat. So it was a habitat effect. So that's just one of many, even though they are in the minority, one of many examples where biodiversity doesn't reduce the risk of zoonotic spillover, or at least by implication. And yet, the messages that we're seeing are quite unidirectional. So maybe I'm answering my own question here, but maybe it is a problem with the messaging rather than the public's digestion of it. Just to add another thought to that, my general approach with this podcast is kind of an assumption that the listener, whether they have a conservation background or not, would benefit from and would understand things better if they were kind of given a bit of credit in terms of what they can take in. I think that we as conservationists very often try to make the message simple, and in the process we make it simplistic. And I don't think that's necessarily the best way to communicate messages. I think that the public deserve a bit more credit, for their ability to understand information than that.
No, I think you're right. I think there are a couple of questions to always ask on when you're given this information, right? So, someone can listen to this and you're a conservationist with a conservationist perspective and agenda. And I'm a dabbling conservationist disease ecologist, but we're both, in that field. And so we have a particular perspective, and we're not necessarily business people or wildlife farmers or that perspective. So if you are more of that end of the spectrum, then you can take what we say with your pinch of salt. And we can do likewise if we're given information. So I think it's always worth asking who is giving you the information. And I think it's almost like everybody is at fault with this ability to communicate science through media to the public and or policy, and the interactions between the two. I think scientists often we're awful at it, and we don't get training in it, and we try to narrow it down to 2 talking points because that's what we learned in media communication, 1 lecture, and that becomes either really dull for the media person who has to try and make something catchy from it, or that becomes the extent of your story, and you've lost all context, and you've lost all the kind of the potential implications or ramifications, or even confessing that you don't have all the answers, but it just comes across as such. So one of the things I've got really excited about recently is storytelling, of trying to give this a local context, and can people relate to what you're saying from the surroundings and the questions that you're asking, and then they can frame it with whatever parallels need to be made. At the same time, that gives more leeway for you to be misquoted or misunderstood. But I'm finding that has to be something that you're okay with if you want to try and communicate with people. Mm-hmm. We do it with relationships and spouses all the time, right? You say one thing and it gets misconstrued, but you get better at the message. And I think when you talk about the public, if I were to be asked about, the financial world and impacts of stock, like I have no ability. I have to take whatever is condensed and given to me. So we all do it. I think I'm going to guess a little bit of humility would be great in all respects, right?
When you say storytelling, I often hear that kind of term used, and actually a past guest was talking about, she's a BBC presenter, and she said that that's kind of her business, is telling stories, and that's kind of how she communicates as well, and she's sort of a professional communicator. But what do you mean, like in your context, what do you mean by that? Do you are you talking about when you have a radio interview, you'll talk about an anecdote rather than a summary of the data? Is that kind of what you're referring to?
Yeah, absolutely. I mean, I think data is one way of looking at things, and I get excited by data. Someone sends me an Excel spreadsheet and I'm thrilled for the morning, but that's not how most people would react, right? And if you talk about, for example, like walking down a coastal scrub in California, like these beautiful clifftop walks, and the Pacific Ocean is stretching out, and then you get bitten by a tick and you hadn't any idea, and you didn't know this was going to be the case, or you went out looking for ticks and you didn't, you were almost doing it as happenstance, and 20 minutes later you've collected nearly 200 ticks in less than half a mile, and they weren't even supposed to be there. Then that gives you a context that everyone can sit there and relate to, as opposed to saying, well, the prevalence of ticks is about 4.3%, but the confidence interval are 0.2 to 7.3. So we're not really certain. Like, it's taken me 15 years to work out how to understand that understanding of those kind of data. Mm-hmm. And I think for conservation, we may be guilty of it just in this conversation now. Like you say, deforestation, as though that is one phenomenon the world over. But if you say, I moved to Fort Collins in Colorado in 2005 and left and came back and was absolutely astounded how massive the city had grown in a 10-year period. It's like there are whole new suburbs, and they're like, that's prairie that is all gone. And that makes more impact to put it in that local context. Mm-hmm. Maybe. Well, you're just a nonsense gossiping storyteller, where's the science? So,
I suppose that the most powerful way of messaging would be a combination of those, right? That you provide both, so that and that kind of covers all the audiences. It's just means a bit more text and a bit more time. I guess that's the sacrifice.
yes. And I think the advice from like media folks is to try and have the story so there's a hook, so that you actually want to find out what the data is behind it, and that you're still listening. Whereas if you're presented with, a results table right at the beginning, it's almost not fair. The scientists presenting that just have to go through a 3-year journey themselves of what was the question and where's the data, and now we've presented it and distilled it. But it's not fair to come up abruptly with that if you don't get the intro and the rationale for why it happened.
All right. Just another quick note on nuance, and this is kind of a little bit of a sidestep from the conversation, but just wanted to kind of get it in there somewhere. I've recently stopped getting my news from specific news sources, especially with the way that the world is polarized as it is these days. And there are a couple of different apps. One of them is called Ground News, and I'm not being paid by them to say this, but what they do is they provide a range of news sources on a particular story. So their staff are obviously categorizing stories that are similar enough to put them under more or less the same heading, and then you click on them and you get literally from left to right of the screen, you get a left to right political spectrum of news sources. Yeah, so most of all, it gives you an idea of how polarized things are. So in rare cases, the left and the right are saying similar things, but in most cases they're saying very different things. So it doesn't really tell you what the truth is, but what it does tell you is that the truth is being warped one way or another, and that's kind of likely to give you a bit of a better idea of what's actually happening. And I guess the relevance of that to what we're talking about is, again, this word nuance, which seems to be dying a slow death at the moment. But at the same time, I think that, like I was saying about giving audiences some credit, I think that people do actually appreciate nuance more than we think, whether it's in scientific fields like ours or just the general news. I think that there's sort of maybe I'm wrong about this, but maybe kind of a growing desire for nuance and for understanding the full picture, not just the sensationalistic headlines. As I say, whether it's about biodiversity or about the latest ongoings in the US government.
Yeah, I mean that's perfect. I mean, I think. Yeah, I do think we get into these camps, like I was talking about earlier, about, is there a dilution works and a dilution doesn't work? And like, obviously there will be cases when it does, and there will be cases, I think at least, and there will be cases when it doesn't. And so the interesting question should be, well, why is it that these different circumstances drive the patterns in a different way? And I laugh out loud because another group in California published a paper on Lyme disease and dilution effect, and it was quite scathing. And it said, the questions you're asking are in the wrong scales, and if you did this, it would come out with a different answer. And I had published a paper saying, well, I just don't think it's a general trend because enough studies are just kind of vague enough, or the confidence intervals are big enough that it just is not a general property of ecology. And both of us, our next papers. One showed how diversity, of adding prawns to river systems in West Africa reduced schistosomiasis. And we did a study on plague or something in East Africa showing how biodiversity actually reduced the likelihood of plague. And I think that's fine, right? We shouldn't be in one camp. You should be looking at the different systems and saying, oh, what is the pattern here? And you don't have to sit there and go, well, I'm not going to publish that because it's just ruined my pedigree now. And yeah, the nuance is really important.
Okay, so that's it for the discussion. Remember to look at the linked resources on the website episode page if you'd like to read further into this topic. There are a bunch of papers that are linked there. Next time, for the first time on the podcast, you'll hear 3 voices rather than 2. I'll be joined by 2 ex-colleagues from my days of working on biodiversity in subnational governments. Grant Pearsall recently retired after decades of work for the city of Edmonton in Canada, and Vidar Narvelo likewise retired after decades at the city of Helsingborg in Sweden. We discussed the general challenges facing conservationists, and more importantly, why and how one keeps going when the odds seem really overwhelming. Through their achievements and their attitudes, both Vidar and Grant have been a huge inspiration to me over many years. And I think that you'll find the lessons that they have to share are inspiring and not just unique to cities, but they apply more broadly to conservation and beyond.